Does Minecraft physics make sense? Well, the simple answer is no. The answer is quite obvious, seeing as the player can carry 100,756,544.9 pounds, or 45,702,400 kilos. All that is roughly a seventh the weight of the Empire State Building, or 36,361 Honda Civics. Not sponsored, unless Honda, you want to get something going? And all of that fits into Steve's back pocket. That is also not including shulker boxes, which would bring the total weight up to 3.63 billion pounds, or half the weight of your mom. Not convinced? How about defying the theory of gravity? I'm not going to even bring up potions. Steve is able to jump a meter in the air like it's not a problem. The player then can go on to jump a 5-block gap and carry on with their day. A YouTuber named Element X discovered the rough weight of a Minecraft world through a bunch of calculations that I won't go through. He calculated that an average Minecraft world weighs 5.62 times 10 to the 20th kilograms, or 562 quintillion kilograms, which is peanuts compared to our Earth's 5.72 times 10 to the 24th kilograms, or 5.72 septillion kilograms. Pluto has an estimated mass of 13 sextillion kilograms. To help you out, here's a photo of Pluto next to Earth. This means that the Minecraft world is smaller than Pluto. The other object seen is one of Pluto's 5 satellites.
Karen
tips the scales at 1.6 sextillion kilograms, meaning it is still vastly larger than a Minecraft world. If you were to travel to the moon of Karen and jump, you'd be able to jump 34 times higher than on Earth, due to the force of gravity only being 0.288 meters per second squared, compared to Earth's 9.8 meters per second squared. With all that being said, 1 meter equals 3.3 feet. The average human can do a vertical standing jump 12 to 16 inches in the air. 1 meter isn't even Steve's max jump. If you add trapdoors, it adds an additional 0.19 meters, bringing the height Steve can jump to roughly 4 feet. He can then jump 16.5 feet, which, to be honest, is not that difficult. The world record for long jump is 29 feet. Now we must keep in mind that a Minecraft world is still less than that of Karen. However, Element X posted his video in 2018, meaning the 1.18 update had yet to come out. Due to the massive addition of the extra blocks in 1.18, we're going to give the Minecraft world the benefit of the doubt and use Karen's mass as a Minecraft world's mass. Steve should theoretically be able to jump more than 34 meters or 112.2 feet in the air. Steve would need jump boost 18 to get to this height. Just based off of this, we can see that physics in Minecraft doesn't make any sense. That was too easy. So we're going to forget about Karen, we're going to forget about Pluto, and we're just going to assume the mass of Minecraft world is the same as the Earth's. Now that our Minecraft world has the same force of gravity as Earth, it seems relatively possible for Steve to accomplish these feats. But you know what isn't possible? Floating blocks! I did a test running on grass and ice. And if you're running on grass, you'll actually reach 100 meters in 14.27 seconds, compared to running on ice at 18.65 seconds. If we were to compare running and jumping on ice versus grass, doing it on ice would increase the speed by 42% compared to just running. On grass, it's only half a second slower. Do you remember when you were in school and your teacher said friction is negligible? Well, not in the real world. Physics tells us that friction always opposes motion. Using Newton's third law, we know that every action has an equal and opposite reaction. This is why car tires have tread. It creates more friction with the ground, allowing the ground to exhibit a force on the car, propelling it forward. We also know that ice has almost zero friction, meaning if you were to try and run on it, you wouldn't get very far. With that being said, the fact that you can run and jump, let alone run on ice, is not feasible. However, skiers use the lack of friction to their advantage. The skis combined with snow vastly decrease the amount of friction in the system, and they use the force of gravity to be propelled down a hill. This is most likely why Mojang decided to make running and jumping on ice just a little bit faster. Steve is able to fall from an infinite height into a cubic meter of water and survive. We know that a fall from 250 feet or 76 meters and any amount of water is enough to be fatal. The terminal velocity of a human on Earth is about 120 miles an hour. That is further increased by standing up to roughly 150 to 180 miles an hour. Surface tension is defined by the tension of the surface film of a liquid caused by the attraction of particles in the surface layer by the bulk of the liquid, which tends to minimize surface area. After falling from terminal velocity and making contact with water, the particles naturally resist, forming a concrete-like layer. If we return to Isaac Newton's third law, we remember that each action has an equal and opposite reaction, meaning that you hitting the water at 120 miles an hour will be like the water hitting you at 120 miles an hour. Mojang did seem to keep surface tension and viscosity in mind, because when you do fall into deep water, you come to a gradual stop as you displace roughly 62 liters of water. So sadly, all those crazy MLGs that you've made, yeah, they wouldn't work. And, well, obviously, they wouldn't work. So if you disagree, I challenge you. Go outside and try some of the following yourself. Now let's see if the bows in Minecraft are accurate. If we were to shoot an arrow from 5 meters away, it takes 140 milliseconds for the arrow to reach the target, making our velocity 35.7 meters per second. That was our horizontal velocity, which will remain constant throughout the entire process. To find our vertical velocity, we can do a similar test, and it comes out to 5.86 meters per second. In order to get our distance, or range, I shot an arrow at 45 degrees, and the distance came out to be 114 meters. Now we need to find the height at which the arrow was shot at. With the bow fully drawn back and pointed at a 45-degree angle, it looks like the arrow is roughly at 2 meters, so we're just going to use 2 meters as our height. In order to find the initial velocity of the arrow, we need the cosine of 45 and the sine of 45. We can then take everything we've gotten and plug it into this equation for vertical motion. 0 being the ending height of our arrow equaled to 2 meters, which is our height that the arrow was shot at, plus 0.815, which is the sine of 45, times the velocity multiplied by time, plus 1/2 times negative 9.8, that is our acceleration due to gravity, multiplied by time squared. Another equation will be used for horizontal motion, where 114 is the ending distance of the arrow, equal to 0, which is the beginning distance, plus 0.525 multiplied by the velocity multiplied by time. Then if we were to go through this equation and divide each side by 0.525 multiplied by the velocity, we would end up with 217.14 divided by velocity equals time. Now we need to plug our value for time into our vertical motion equation. Going through it, our velocities cancel out, and if we multiply 0.851 by 217.14, we get 184.8. Multiplying 1/2 by negative 9.8 gives us negative 4.9, and if we were to square 217.14, we would get 47,149.8, and that would be divided by velocity squared. Adding 2 to 184.8 gives us 186.8. Multiplying negative 4.9 by 47,149.8 gives us negative 231,034. We can then bring our negative value across the equal sign, making it positive. Multiplying both sides by velocity squared gives us 231,034 equal to 186.8 multiplied by velocity squared. By dividing both sides by 186.6, we get 1,236.8. If we were to square root that number, that gives us 35.2 meters per second. That means our arrow has to travel at least 35.2 meters per second in order to reach 114 meters. Going back to our horizontal velocity of 35.7 meters per second, we see that the bow in Minecraft is perfectly capable of doing this. So does that mean physics in Minecraft actually makes sense? Well, yes, but not really. What we just calculated uses the acceleration due to gravity on Earth, not on Charon. So if we're being realistic, the answer is no. If you enjoyed this video, don't forget to leave a thumbs up, subscribe, and share. This video took a lot of time and effort, so it would be much appreciated. And I'll see you next time!